I want to replace this system with a single resultant force, and I want to figure out where to place that force, basically along the line AB. Hopefully between A and B, but again, it could be anywhere along that line. So again, what I'm going to do here is I'm going to do this in two steps. I'm going to first bring it down to a single force and couple moment. Okay. At the point A. Then when I have that, I'm going to move that resultant force some distance along the AB axis D so that it creates an equivalent resultant moment, right? So it's a two-step problem. Then all of these systems will have the same external effect. Okay, now the resultant force is very easy. I just add all of the forces together. So I have negative 10J, I have negative 40I, and then I have the 25 pounds, which is plus 25 cosine 60 in the I direction, plus 25 sine 60 in the J direction. Adding all of those together, I find a resultant force that's equal to negative 27.5 I plus 11.7 J, and that will be pounds. So that's the resultant force, okay, when I move it all to point A. But of course, these create moments, okay, that I have to add up to find the resultant moment, which of course is any couple moments plus any r cross f's. Now I do have a couple moment, which is that 80 pound inches, so I want to make sure I include that. Again, its location doesn't matter. It's a free vector, so I can move it wherever I want to at any point. But then I've got, again, I'm doing this about point A, right, because I'm moving everything to A. So that 10 pounds does not create a couple moment. The only ones that do are the 25 and the 40. Okay. The 25, I'm going to take the 12 inches. That's the horizontal distance times the vertical force, which will be 25 sine 60. Right. The horizontal component of that force goes right through point A, so I don't have to worry about it. And of course, so if I have I'm breaking that up into those two. The horizontal goes right through A, and that's creating a positive rotation about point A. That's where that comes from. Now I've got the 40, which is down below. It's going to create a negative moment. So I'm going to take a negative 8 vertical distance times that 40 horizontal distance. From this, I get a resultant moment of positive 19.8 pound inches. Okay? So that's the two forces move to point A. But what I need to do now, again, is basically set that resultant moment equal to some d vector crossed with my resultant force. Okay, I know my d, I want the horizontal distance, so that's going to be in the I direction. So my resultant force, again, is 19.8 K. My D is, I'm going to call it DI. Again, I want to know along that AB axis. So that's the horizontal axis. And I'm going to cross that with my FR, which will be negative 27.5 I plus 17 point, or 11.7, excuse me, J. Okay. When I do that, the I cross I equals 0. So what I'm left with is 19.8 K. I cross J is K, so I get 11.7 times dK. So then I just divide 19.8 by 11.7, and I get D equals 1.7 meters. So I put this force, negative 27 I plus 11.7 J, I put that 1.7 meters to the right of A, and I have a single force at a specified location that gives me the exact same external effect as those three forces and that couple that I have on the original one. So it's just a way of simplifying several loads down to a single point load. And again, I can do this because it's a 2D problem. A coplanar problem, I can reduce it down to a single force at a specified location.